Okay, yeah, thanks, and thanks for inviting me. And I'm happy to share some information about a case study that we published last week together with the WBCSD in the course of the A-Track program on the use of location-specific data to evaluate our feedstocks. Just very brief, who is Henkel? Who are we? Henkel is a company based in Germany, and since about 150 years, we manufacture consumer brands and adhesives and sealants. So you might know some of our brands like Persil, Schwarzkopf, whatever. You might find them in your bathroom if you have a closer look. And our motto is "Pioneers at heart for the goods of generations." From that theme, you might get the idea that we are also looking into sustainability for our business a bit. And we're having a sustainability ambition framework, which comprises 3 main pillars. The first one is the Regenerative Planet pillar. That covers climate, circularity, and nature. Then we have Thriving Communities, which is all about social topics. And we have the Trusted Partners, which is on our business relationships, our performance, and our governance. So that as an overview. And today I want to bring a challenge to you, which we found in the Regenerative Planet pillar when we're talking about climate and nature, basically. As you can imagine, as Henkel being a company with a very broad product portfolio, we also have a very broad raw material portfolio. And now when we look at these raw materials, they can be based on a variety of so-called level 0 feedstock. What is a level 0 feedstock? A level 0 feedstock is basically the feedstock that can be grown on a field or that comes directly from a mine. So we're talking about the thing that is really in closest contact to nature. And when we have those level 0 feedstocks, they can also come from different potential sourcing locations. We take an example. We as Henkel purchase a C16 fatty acid. That is a relatively common product that you need for cosmetics and whatever. We purchased that from another company that purchased the raw material for that from another company, and so on and so forth. And when we try to trace it back to the feedstock, it already gets complicated because you can derive a C16 fatty acid from palm oil, you can derive it from rapeseed oil, you can derive it from beef tallow, or you name it. So variety of feedstock, already difficult to get the transparency to the level 0 feedstock, and then close to impossible to identify also the sourcing location for that level 0 feedstock. Because if, for example, we already know it is a C16 fatty acid from palm oil, then we have to identify, is the palm oil located or coming from Malaysia or Indonesia or whatever. Palm oil is maybe not a good example because there the transparency is already quite high, but you can imagine it's a bunch of different level 0 feedstocks coming from a huge variety of potential sourcing locations. So our question is now, how can we identify likely level 0 feedstock sourcing location combinations? And if we have a combination that is likely to be possible in our value chain, what are the impacts on nature? And are there any risks related to natural disaster, for example, for this specific feedstock sourcing location combination? If so, we can act and find an alternative to mitigate our risks. So this is what it's all about, evaluation of the interaction between our raw material supply chain and nature on the level 0, so to say. So what did we do to actually tackle that problem? So first of all, we identified the level 0 feedstocks that are potentially there in our value chain. We ended up with around 140. I guess that most companies who are producing different products will end up in the range between 100 and 150 different level 0 feedstocks. Then we took a lot of statistical data to identify the potential sourcing locations of these feedstocks. So for example, for bio-based feedstocks, you get Faustat, which is a database on the production of crops. You will find lots of production volume info. So you can say, okay, if I have this and that level 0 feedstock, it is likely that it is grown in country A, N, and Z, for example. So we already have that combination now. What we did then was we take the level 0 feedstocks and we assigned so-called environmental pressure factors to each and every level 0 feedstocks. Now, what are environmental pressure factors? We identified, based on the planetary boundaries concept, 4 areas of working that are A, out of boundary in terms of the planetary boundaries, and B, directly influenced by us. This is climate change, freshwater use change, land system change, and novel entities. So we said, regarding to related to these specific topics, can the feedstocks that we have put a pressure on the environment, so make the environment worse? Easy example, freshwater use change. You have a level 0 feedstock that uses loads of water for growing. If you have an agricultural production system, then obviously the pressure on the surrounding ecosystem is relatively high because a lot of water gets taken from the ecosystem. And this is basically the environmental pressure factor. How much pressure is the feedstock putting on the environment? And then on the other hand, we took all the potential sourcing countries and we assigned so-called environmental influence factors. That reflects the current status of the ecosystem that is present in that country, basically. So we stick to the example of water. If we have a very water scarce country, the environmental influence factor is defined to be very high, because we already lack water, and this is what Bianca just told also in the last presentation. And now if we take water, even just a little, from this country, we have a relatively huge impact because the surrounding ecosystem is already stressed. And vice versa, if the ecosystem is already in such a bad state, that also puts a lot of risk to our country as a sourcing region, because if the ecosystem fails to provide the usual ecosystem services, then our sourcing might be limited there. Okay, so now we have that huge list of combinations between the level 0 feedstock and the likely sourcing countries, and an environmental pressure factor of the feedstock, and an environmental influence factor of the country that we're looking at. Now, from that, we combined these environmental pressure factors and the environmental influence factors to a so-called environmental impact factor. That is then basically just saying the impact factor is super high if the pressure and the influence is super high. So a combination of that to reflect that for some feedstocks, it might be worse to source them from one country than from another country. And to do a bit of more mathematics around it, we also calculated an average of those 4 environmental impact factors. We're still with climate change, freshwater use change, land system change, and novel entities. And the average of those is then called the nature impact factor, which is the one single value to compare to level 0 feedstock sourcing country combinations. From that, you might, for example, find out if you source corn and you source it from the US, the nature impact factor might be lower than if you source the very same corn, but from Saudi Arabia, because in Saudi Arabia, you're more water scarce, and therefore the environmental influence factors are higher, and therefore then the nature impact factor gets higher. So that's how the entire logic works. As I said, it has been published last week. So if you want to have a bit more deep dive into the methodology behind it, you can have a look at that. How does that then look like in practice? We used all those data and created a nice dashboard, because dashboards and visualizations is always what people like. We now start at the right-hand side. That is the first page that you will see on the dashboard, the so-called feedstock evaluation page. There you can type in a potential feedstock that you want to use. And then the dashboard on this map will show you where you can probably source that feedstock. So all the countries that you see here that are colored are the potential sourcing countries. the darker or the more intense the color gets, the more likely is that you source it from this country specifically, based on, as I said, statistical data. And then it also tells you which country would be best from a nature impact point of view. So the greener it gets, the lower the nature impact factor. Good sourcing country because not too much risk and not too much pressure on the environment. The more reddish it would get, the worse actually, because then you would have A, a high pressure, and or B, a super high risk of sourcing it there. You also get some additional information. You get a breakdown of which of the environmental impact factors is the worst. In this case, for this feedstock, it would be water. And you get some additional information on the bottom right, if that feedstock is relevant for the EUDR, or if it is listed on the SBTN high impact commodity list, or if it's a conflict mineral. And for example, this one is on the SBTN high impact commodity list. It will also tell you why it is there. So that's all the text information that you get. Then in the middle part, you can also split that. You can also have a look at the countries that, itself. So for example, this picture tells you which countries are most sensitive to land system change. And then in the middle on the lower picture, you can compare two different feedstocks directly, say feedstock A and feedstock B. I can source it from whatever 3 countries. And then you can see, okay, feedstock A would perform better from a nature impact, or feedstock B would perform better from a nature impact. And is it actually likely that I can source it from that desired country? So that's how it looks like. Who is using it? Currently, our purchasing teams can use this dashboard to find alternative sourcing options if they see, for example, that we source a raw material based on a feedstock from a very sensitive location. One can try to find another option to reduce the environmental impact. Then our product development teams can use it if they develop new product formulations and see, okay, is the feedstock that they are using actually good for the environment or rather bad for the environment, and then potentially switch. And this is actually the main use case for the time being. Our risk assessment teams use the tool to identify feedstocks that are at risk, not only because the environmental condition is already that bad, but also because it's feedstocks that are sourced from 1 or 2 countries only, so that you don't have too much space for mitigation if you want to source your feedstock from somewhere else. So these are the use cases. The entire tool can be used to inform the assess step when we're talking in the XD framework, which is also the assess step in the SBTN if you want to set science-based targets for nature. If you're more into the TNFD LEAP approach, it would be the locate step, which is the relevant one for this tool to come into place. Because we also talked about whom to engage in a company like Henkel, which is globally active with loads of different functions. We made 2 rounds of involvement, actually. So we had an initial development of the tool that was led by us being the global sustainability department. We did the method development, and then we involved the sustainability analytics team for the integration into that dashboard and doing the IT landscape around it. Then we involved the sustainable purchasing teams to identify the level 0 feedstocks that are relevant for us, and the research and innovation team to review the key performance indicators that were used to identify these pressure and influence factors. And with that, we came to a, let's say, alpha version that then ran into a lot of feedback loops and training sessions for other teams. So for example, with the risk evaluation experts, but also with sustainable purchasing experts from the different business units and R&D experts from the different business units. And based on the feedback, we are now with the beta version, so to say, that already runs relatively smoothly. We did the last update yesterday with the new export statistics from OECD and Faustat. And yeah, so we're happy to see where that is going. maybe we can improve the data quality. It is still, as I said, statistical data. Some is maybe not as accurate as we want it to be. We think about including also social aspects, for example, risk of child labor, risk of human rights violation, and so on and so forth. And we're happy to see how this proceeds. So that's what I wanted to present today. Happy to take your questions, and feel free to copy the approach.